Oh, it looks like we're live. I'm used to a confirmation dialog there. I guess that setting got turned off somewhere. Cool. Are we still live? OBS just had a hiccup there. Alright, a bit of a rocky start there with the encode, but I think we might be live. The computer is working a little harder than usual right now, but I think it can handle it for once, I hope. Alright. I think we're still broadcasting. Okay, cool. Yeah, so late night stream tonight. I ended up spending a lot of today doing hardware upgrades and Windows related fussing on the machine that we've been working on. It is now on an SSD and it's running a much faster GPU. And I think we are almost to the point where we can actually get some real-time output from the computer vision code. So that might be a good goal for today's stream. So, hello. Here I am. I don't know why the camera has so much trouble with this nighttime scene. It just overexposes me so much because the background is so dark. I can crank up the lights in the rest of the shop to some extent, but it doesn't help that much. So, anyway. Oh, Mitch Beyersdorfer in YouTube chat says hello. Hello. Always nice to see who shows up when I do the streams that are in different time zones. So, this came up in a conversation from the conference I just came back from, Besides PDX. But we really needed this to be just a slide that is available on my broadcasting setup here. So I can just click a thing, and now we just have this. So if we're ever just stressed out, we just need somebody to hang out with who's obviously having a good time, and we can just let some of that relaxation rub off on us, then there's this video. Also tea. Tea is pretty good. So technically it's not tea. It's mint leaves and almond milk in hot water. But I don't know what else to call that rolls off the tongue, the way tea rolls off the tongue. So yeah. It's just a thing I can just poke the button and I get Relax Tuco. Well, I haven't actually mapped it to a physical button, but it's on the list of scenes here on the broadcaster doodad. So yeah, I've got that. Anyway, I've also got an exciting thing on this channel. Oh man, look at that. We've got, here's all the sensor data from the robot in real time. All them nice little graphs. That's the motion sensor at the bottom, so if I just like physically move around, then you can see that number increases, and if I stand still, it decreases. And so it kind of averages out to roughly the level of large radio reflective object motion in the vicinity of the robot. And then these are distance sensors, which right now are just fluctuating a bit due to the motion of the objects here, but if I put my hand out here, you'd see I start blocking the distance sensors. This distance sensor is aimed up here right now. And then these are the short-range IR sensors, which right now are not giving very useful results because I need to make little calibration mounts so that I can actually aim each of the sensors, because right now they aren't aimed well enough to be useful. But electrically and software-wise, those are working. And then we've got some outputs from the inertial measurement unit. So there's acceleration, and then the angle estimate from its Kalman filter. So, Ear says my task manager doesn't have a GPU panel. Hacks. I installed a special Windows update today just to get this GPU panel. So it isn't hacks, it's just new. And it doesn't really seem to work especially reliably. Like the 3D percentage here, I don't entirely trust it because it actually has been going down on workloads that I think would be using the GPU more. So there are a lot of explanations for that, like perhaps it's including the time spent by certain types of GPU stalls, so that on those light workloads the GPU is actually spending a lot of time, just a lot of that time is spent waiting on the CPU to say go ahead. So there can be stuff like that. The Microsoft blog that I read about this on said that it's very experimental. Nothing seems to be showing up on compute right now, despite the fact that I'm actually hitting CUDA pretty hard right now. So there might be some other NVIDIA tool that gives me a better real-time view of what's going on. I was still trying to do the research to figure out what that tool would be. If anybody out there right now actually knows off the top of their head what that is, that might be helpful. But yeah, I was trying to get a sense for just what the different parts of the system were doing, since I'm doing so much on this computer right now. There's the one copy of OBS that's doing the broadcasting, there's the other copy of OBS that's running the computer vision and the broadcasting for the robot, then there's the actual robot software. The robot software has gotten to the point where it no longer runs fast enough under a debug build of in Rust, and so the debug builds are especially slow. I think most Rust programs are just pretty slow in debug, but this particularly, I think some of the libraries I'm using just end up being really slow because some of their abstraction boundaries end up kind of having a much greater cost in debug than they otherwise, otherwise they would have almost no cost. So yeah, I've had to switch to release builds, but in a release build, the robot server runs quite fast and it just keeps up with the messages no problem. So it's this, can we actually sort this? Yeah. So Chrome here is struggling to render all these canvases over and over again. And then we've got these two instances of OBS that actually are not using that much CPU because a lot of the work is being done on the GPU. And then Ableton is down here doing the audio and just waking the CPU up super frequently because I've got super tiny buffers on there. And this bot controller is the actual Rust's process, and it's drawing like 4% CPU right here, 3% CPU. And it's also like the audio going to just be waking up super frequently and doing a little bit of work and then going back to sleep. Oh, Peter says the Tuco Flyer stream is not online. Oh yeah, actually we could try turning the stream on. Yeah, we should try that. Get a sense of what the workload ends up being like. So we want to go back to this. Let's open that up in another Twitch window. And I preemptively mute this tab. All right, so over here, you're skipping ahead a little bit, but yeah, so this is the work in progress OBS, and so this is the view from the tripod, and this is the text overlay that we've been working on. I spent a little bit more time optimizing it since the last stream. This implementation actually double buffers the whole vertex buffer thing, so I just have 2 vertex buffers, and I take a heavyweight mutex that just stops until the graphics thread can synchronize if I have to resize anything, but I try not to resize often, and if there's no resizing, then I can just use an existing pointer to write to a back buffer that gets synchronized to the vertex buffer by the graphics thread next time it renders. So in practice it becomes pretty much lock-free, and it seems to be working pretty well. So there's a WebSocket thread that mostly just gets to sit there waiting on messages and parsing JSON. That was another bottleneck. The JSON library I was using Jansen, which is the same JSON library that OBS uses for like config file kind of stuff. It's not at all performance critical there, but when I'm using it to parse like hundreds of kilobytes per second of JSON, it tends to do a malloc for every single JSON object, and it has no facility for like custom allocators to mitigate that. So I switched back to my old friend RapidJSON, which I've used for a bunch of projects where it's performance critical. And the idea behind RapidJSON is you have a single memory pool that you allocate per document, which is basically append only as you parse it. And you have these tiny records that all are just like zero copy references to the original data, and it's much nicer. So I'm using RapidJSON now. I just parse the document once with one allocation, then I go through all the message type specific logic to get something done depending on what message it is coming from the robot server. In this case, if it's to draw the overlay, then I'm actually just picking apart all the data from that message into a vertex buffer, which then goes through this lockless queue into the rendering thread eventually when the rendering thread wants to draw it to the screen with Direct3D. So much better. Anyway, yeah, let's see if this works with the encoder also. I think I've already got this set up. So there should be no audio. We should be streaming the same thing I'm showing here. Oh yeah, Tuco Flyer just went live. I think this one's doing CPU encode right now, but if this chart is at all to be believed, then I've got plenty of spare GPU encode space, in which I would expect so, given that this is a... So I upgraded from a GTX 745 to a GTX 1080, so it's a big improvement. This one barely fits in the case that the computer's in. But it finally has the power to run the computer vision stuff real time, no problem. So, yeah, I think the streaming's doing all right. I probably shouldn't leave this running unattended because I don't want to get banned or whatever, but once I've got the computer vision running, it might actually be interesting enough to start running a little bit more. Because we are getting really close to being able to overlay the computer vision results on top of the video and then stream that. Mikey asks if I can fix the camera. No, I've already tried the obvious stuff. I can't fix the camera. The driver doesn't seem to have an exposure control that actually works. I mean, we have done a couple of Windows updates since I tried last, so I guess I could see if I could check again. But yeah, last time I looked, I couldn't fix this unless I like poured tons of light into the back of the shop. Which maybe I should just put a backdrop up for nighttime filming. Yeah, so there's a bunch of like sound and focus controls. Oh, this actually might be a new Logitech driver since last time I tried this. Can I disable auto exposure? The exposure control does not seem to work. See, I can turn down brightness, but you can tell that that's just decreasing the values after they come off the sensor and after they've already been clipped. Ugh. And then... Can I... Oh, okay, there's like a musical checkbox thing. I can uncheck that checkbox, then uncheck that checkbox. Oh, is that gonna stick? Is it? Oh, is that actually gonna stay? I think I've managed to turn off auto exposure. And so I think it's manual now. Okay, that's actually really good. Well, thanks for bugging me about it. I thought I definitely checked this before and hadn't gotten anywhere, but I think a couple of Windows updates later and I actually have better drivers for this camera. That is chunky steps, though. There's exposure, which seems to lose detail really quickly. And then there's gain. Okay. Not really sure what the difference is there. Okay. Well, yeah, that is nicer than the completely messed up auto exposure. Thank you. Will this stay when I close the dialog? We'll see. Will it stay? I think it stays. Okay, cool. I'll celebrate with some tea. Of course, we still have the problem that the lighting is super non-uniform here at night, but at least now I can change the exposure within a reasonable range just by leaning closer or further from the light. And really, the microphone has a sweet spot too, so. Anyway. So, you might notice that we're rendering some text. I had it resized here just so that you can see that it is actually rendering past the end here. And the text here is actually just, it's coming in the form of a list of copies from a texture to the screen. And then we convert that to a vertex buffer and then just draw the vertex buffer. So we never actually have to build the whole texture on the system memory side. We can just have the GPU do that part. So if I'm actually running this full screen, it looks like this. And I think it looks pretty good. So that's kind of the zoomed in view of the OBS side. And then you can see that on Twitch, it's actually broadcasting full screen. So, man, anybody tuning in only on Twitch right now probably thinks I'm broadcasting some kind of weird number station. So, anyway, speaking of this, we should actually be able to see fairly real-time correlation between the sensor data and the numbers. I mean, the numbers you're seeing there and the video. So, let's see. For example, you can see these LiDAR ranges, and then if I move my hand, you should be able to see at some point I'll hit the active area of one of the sensors and that number will jump. Maybe it's hard for me to do watching the screen that has lots of lag on it. So I mean, they're definitely moving, but it looks like the edge of the beam is right about there. You can see right about there it goes down to about 10,000 on that middle range, or sorry, 100,000 rather, and then back it out and it's about 140,000. Might be nice to have a drawing system for doing tiny little graphs on the screen too, but we've already got the web interface for, you know, well, not that, this. We've got this for nicer graphs. So yeah, and then on the Rust side of things, I've been building up sort of a tiny graphics library that you can use to put nicer stuff like this on the screen. So it knows about text, it knows about fonts, it knows about measuring text and putting it in a fancy box, and it knows about foreground colors and background colors and line thicknesses and stuff like that. So, the Twitch number station. Yeah. Well, I mean, this is sort of a... I mean, this is also already running the computer vision, and so you just can't see the results, but it's already got its own idea about what's going on here. The auto exposure seems to be a little bit smarter on this camera. It's a little slower, but see, that is a much nicer seems to be higher dynamic range. The white balance is a little bit off, but that could be my fault. Alright, well, at some point I'll have to stop the stream because I plan on recompiling the program that's doing the streaming. But yeah, I guess this is pretty much the demo of what we've got so far. The robot server is that little thing running back here and displaying the QR code. This same thing that it splatted to the console with the URL and the QR code, it also saved that to a text file, which in OBS we've actually linked to the little filter plugin. So if I go in here, filters, flare camera filter. So it's asking for a path to this controller connection.txt, and so that's the file which automatically gets this stuff written to it. And so this automatically reads that file, and then, wow, there's a lot of lag on that camera. I think I forgot to, when I rebuilt this scene, I forgot to turn off buffering on the Blackmagic device, and I think it's getting behind. Let's see if I can fix that. Not filters. That is much lower latency. Okay, that is much better. Okay, I'll have to remember that. Anyway. So, yeah. Sorry. Text messages and trains of thought don't get along. So, flare camera filter, connection file, and then we also give it this texture, which, this is just because I don't want to have to pass the texture image data over the WebSocket. The WebSocket thing is designed for just like repetitive updates, and I didn't want to have somebody like be able to ask it for the texture and have it send, so it's just like, I just wanted to point it directly at the PNG file on disk. And I figured it was pretty reasonable to just stuff everything into one texture. So right now this is all being handled by this freeware, well, I think it's actually open source, but this pretty common tool for like Windows game development called BM font. And there's actually already a Rust crate to deal with rendering text using the output format that BM font generates for the Atlas here. So it generated this image, and then it also generates a data file which the Rust code loads, and then uses to generate its list of, you know, which rectangle goes where. So that list of rectangles comes over the WebSocket, goes into a vertex buffer, and then we draw it here. And yeah, there's a lot of code behind that. That's fine. And this computer is so much happier. So the GPU is new, and I also transferred the file system onto a smaller SSD, which was kind of annoying, but it felt like a small victory to do it without actually reinstalling Windows. And since I had this extra magnetic disk, now the recording disk is striped, which is slightly handy when I'm copying gobs of data onto it or off of it. Anyway, I think I'm going to actually stop this because I want to run this in the debugger so that we can see the output, because right now the computer vision code is running, but the output is only going to the debugger. Oh, it might not shut down. This is a known bug. I think the computer vision thread is blocking waiting on a frame, and I don't yet have a way of telling it to stop waiting during shutdown. Oh, concurrency. I've been putting off fixing that bug, but it would be nice to fix it. What do you think? Should I fix it now? Should I procrastinate and try to get the computer vision output working? Oh, that's interesting. Is there some support for switching GPUs per process, I guess? Or maybe it just tells you what it's spending the most time doing GPU-wise. That's interesting. Anyway, I killed the zombie OBS, and now we have this. I vote computer vision. Yeah, we can go ahead and put off the technical debt for later. Okay, well, again, I don't want this editor, but let's just run this so we can see the output, because, yeah, output. How do I maximize this? None of these windows are in useful places. Okay. Anyway, I can't even see what's going on because this is over top of my other window. Okay, so OBS is running. Sorry, it was on the other screen. And look at all that debug output. Wow, so this number in brackets is the index of the object that it's detecting, which is just an arbitrary number that, it's just the objects that were over some minimum probability threshold in that particular frame. Right now, it's making no effort to track objects between frames. There is some code for that in this library. I'm just not using it yet. And I may or may not actually want to, because most of the object tracking I want to do is about tracking a single rectangle. And so anyway, we'll see. So it was detecting like 10 objects here, and it's just quickly giving us the pixel coordinates, which are kind of hard to visualize. A lot of these are person objects, so I guess it's detecting a bunch of parts of me. Probably because it probably doesn't detect the black shirt on the black background very well. If I try to make that continuous, like, okay, I've got to look at the right camera. So, fewer people. Anyway, person, cell phone, motorbike, I don't know. This is not the fancy YOLO network also. This is like one of the smaller YOLO networks. So now that I've got the faster GPU, actually, I should switch to the bigger YOLO network, since it doesn't seem to have any trouble running this one. But before doing that, we should probably just get this to visualize the results. There are a lot of ways I could do the visualization, but right now what I want to do is actually just get this output to go all the way into the Rust process where I want it to go anyway. And then since I've got this drawing library in the Rust process, I can just use that to draw the computer vision results. So this will be a test of getting the data end to end from the plugin to the bot server and then back to the plugin. Here says it's the diagnostic tool saying the process is using 3 gig of memory. That sounds about right, yeah. I mean, the regular OBS uses like 1 gig with all the graphic stuff that's going on. And yeah, like another couple gigs for the computer vision seems about right. This stuff is very memory hungry. Alright, yeah. So all of this stuff is happening on a separate thread that's just doing the computer vision. Looks like that time it actually exited. How about that? Oh yeah, I want to, maybe while we're here I can show you, if we have a model cat around here, I can show you how well it detects cats. Let me see if Tuco's around. see him down here. So I guess I'm the star of the show for now. Oh well. I'm in no danger of running out of memory on this machine, but thanks for your concern. This machine has 16 gigs, and we're not in danger of running out. There's 16 gigs of RAM on the motherboard, and then I think another 8 gigs on the GPU. Alright, well, back to the text editor. Huh. Oh, the Cozies in Twitch chat says you use Ableton for streaming audio, question mark. Yes. Well, I mean, I don't use Ableton for the streaming, but I use Ableton as part of the mixing process. I mean, it isn't involved at all in the streaming. The streaming is all done by OBS, but there's a separate audio interface that Ableton's connected to. Am I streaming that? Yeah. So this has got a bunch of channels with the different inputs and outputs. I use this for making recordings when I'm actually doing audio that I'm going to be editing into a video. But for this stuff, like, you can see that it's running some compression and some filtering, and then I can throw together whatever channels I want from whatever sources, and then record it locally here, save the original multiple tracks so that I can re-edit them later. But when I'm just streaming, then this is just doing stuff live and not actually saving. And I just leave that minimized, and OBS does its own thing. And OBS is just getting this in through the aux input there. Alright. This is our interface to the WebSocket. Let's clean this up a little. Alright, so I need a way of sending any message, or just sending, what do I want to be able to send? I'm imagining a function that I can call from any other thread that posts a request to eventually asynchronously send something over the WebSocket. Maybe that something is just a string of, like, just already encoded JSON. I'm getting a little ahead of myself, though, because actually the next step here is we need to implement authentication so that we're allowed to send stuff. But maybe it's worth thinking about how sending works so that I know how, like, when I'm allowed to send. I'm going to be serializing all the WebSocket stuff into a single thread. So there's one thread that handles, it has the event loop for receiving from the WebSocket, and I can post events into that thread from elsewhere to handle sending stuff asynchronously. So for authentication, we get this authentication challenge message. Then we have to do a cryptographic calculation with the challenge and our key, and then send the challenge, or send the response back as another JSON message. The vision is happening over here. This has a very opaque interface. You start it, you give it an image grabber, which is just this thing that knows how to wait for images and then gives you pointers to them. And internally to that flyer vision thing, it starts a thread for this YOLO computer vision object detector algorithm. And so that does the initialization and the detection over in a separate thread, because the initialization takes a while too. Oh, I had a delay here. That's right. I had this delay here because otherwise it was just completely killing my machine by trying to run the object detector continuously. But this would be limiting it to 10 frames a second. So let's see if we can triple our frame rate by removing that delay. This shouldn't have any trouble keeping up with this GPU, but let's just try that just to make sure. You're asking what C++ standard version this code is getting compiled at least C++ 11. Alright, so there's our thing. I mean, a lot of OBS is in plain vanilla C, but then other parts of it are in more modern languages depending on what platforms that particular part targets. Alright, output, anyone? That's neat. We're getting any more GPU usage than before? And that looks like more is going into that bin. But yeah, it's kind of hard to tell how fast these are coming out, but they definitely do seem to be really screaming out of there. Yeah. Well, great. Let's try to get them out of this thread. So I think the way this will work is I'll have some code in this file probably that knows how to take these boxes, so the output from the detector, and it'll be assembling a bunch of stuff on the stack, just in the local scope. Some strings, some rapid JSON value objects, rapid JSON document, and all of this stuff together will be the stuff that we want to send over the wire. And then it'll serialize it, and in that moment, serializing it, you can actually copy all of that other disparate stuff from the stack into a single buffer. And if that buffer is something we can transfer ownership of easily, then we can just send that to the other thread where we can copy it again into the WebSocket internal buffers, however that ends up happening. So yeah, let's take another look at, it's been a while since I've used rapid JSON in this kind of detail, so let's take another look at the serialization APIs and see what we have to work with. Reference is maybe what I want. String buffer, yeah. Yeah, I mean, I guess I could just allocate one of these on the heap. And it'll also have its own internal string and all that, and bunch of memory allocations that have to cross threads, which isn't amazing for performance. I mean, it'd be cool to just have it be a single memory allocation, which I could get away with if I just made it a plain old malloc C-style string. Probably isn't worth the effort to try to actually write something like that. If, you know, I think I might just try doing this straightforwardly with one of these string buffers. Okay, so that's probably the interface that I want. I want this bot connector to take. Yeah, I think that's all right. So this will just be for sending arbitrary stuff. That's right, IO service. Look up how to actually send the invocation over to that thread. I remember there being a method to do that. Dispatch. Yeah. Yeah, and then for this. Oh, I'm out of tea already. think I need to have another little mutex protected member variable for passing the current connection pointer back out. Something where like you can take the lock, and then if the connection pointer is not null while you have the lock held, you know the connection will stay around long enough for you to dispatch the message to it. And that wouldn't be necessary for in the case of the authentication challenge reply, because there you're doing it from inside of an incoming message. You're replying to a message so that you have ready access to the connection pointer right there. But for the computer vision stuff, that's coming in asynchronously. So like, you need to think about what happens if that message comes in while we're trying to tear down the thread, and like there needs to be a consistent ordering there. You know, and then we can just like lose the connection for a lot of reasons, not just restarting OBS, but you restart the Rust server, or there's, you know, some transient problem that causes the connection to time out, and then it'll just reconnect. So where does the connection start existing? Right now, I don't think we're actually hooking the open callbacks. Yeah, so we allocate the connection here. We probably can't actually send stuff to it until it's actually been established. So maybe we want to save it at that point. And then right now, the close and fail handlers are just getting bound to this reconnect function directly, which is not what we need to do. All right. I think fail I can still bind directly to retry. Oh, sorry, close, not error. I think this HDL thing means handle, which might be a smart pointer. No, maybe not. What is that data type actually? Ah, it's a weak pointer. Huh. Wow, that's a surprising guarantee, actually. That's actually kind of helpful. It's a thread-safe weak pointer. Nice. I assume I still need a mutex to protect, like, this object itself. I mean, I'm planning on actually accessing this memory that's in this object that was owned by this one thread from any other thread, so I think I need a mutex for that. Oh. Actually, no. Access to this is serialized entirely by being on the WebSocket thread. Because I don't need to know this value before I send the message. I had made an incorrect mental assumption in thinking about how that send was going to work, where I was like capturing that connection variable and then passing it into the thread, but the thread should just look that up from the member. Like, I should capture this into the thread. But that's it. This will be a version that assumes you're already on the local WebSocket thread. And then I have that active connection handle. Can I set these to 0? We'll find out when I compile this. Actually, I should look at the constructor, because if it's... I might just have to call the constructor without an argument to get a default value. It's a weak pointer. Where's that weak pointer defined? Is lib here? I assume that was something built in, but maybe this is like an STL thing. Seems likely. Yeah, I think my hunch was right. I think we need to just assign this to something like that. this will end by deleting that string buffer. Until then, let's also take a look. Oh, right. We were just talking about how I don't actually need a lock for that. These are on that thread. Right. Single-threaded programming is where we're at right now. And can I test this with an if? I'd like to know if I can tell whether this has been assigned. Like, is there a current connection? Is an empty shared pointer like a null pointer? I guess here they're showing that they're just testing it like there's a Boolean operator. Yes, this has a Boolean operator. Cool. So I've got to lock it, then that gives me a shared pointer that I can do a Boolean test on. I don't want to just do that right in the if, because I actually do want to keep that shared pointer in scope so that I can be sure that the weak pointer stays as long as this function is running, which shouldn't be a problem. But theoretically, if I was doing multiple things with the socket and the socket lost the connection, then maybe the weak pointer would go away otherwise. I don't think it would be a problem since I'm actually passing the weak pointer into all the API functions. I would think that it would actually do that check. Anyway, is there a type def for that? Weak pointer to void. Whatever. Okay, I think I can mostly just call send on this. Is that on the handle? Ah, I guess I do need to upgrade this to a full connection anyway. I think. Yeah, okay. And is this where I saw that send function? Yeah. Yeah. Oh, but this takes a connection handle. So it takes a connection handle, but I'm calling it on the endpoint, which I need to get to through the connection. I don't quite get that. Oh, what is this opcode thing? I think that's like text versus binary. Frame opcode value. Ooh, text binary and a bunch of reserved stuff. Neat. Okay. Oh, that endpoint was something I'm supposed to already have. I think that client is a type of endpoint. Yeah, thread client. Okay. So that would be... Oh, what am I getting? Got string. Can I get... I'm thinking about the string count. Yeah, these all want a length. to go over there? I need to know not just the pointer to the string, but the number of bytes in the string. Okay, get size, number of bytes. And that opcode. Okay. I think one way we might be able to test this pretty quickly is by just sticking a debug function in there that just fills the buffer with some junk and then calls it, and I think we'll get an error out on the Rust console. Can we test this theory? Okay, there's the fire hose of messages. Just give it some stuff that won't parse. Did I not have that? Spew debug logs? Maybe not. Okay. Well, maybe we'll have to add that back in. I think that'll work. I'm relying on the closure to grab that variable and the this pointer and send them over. Okay, let's take a minor detour to Rust so that it prints out error messages. Oh, you know, it might just be sending the error messages to the client. I think I might have taken away the... Yeah, I might have taken away the printout there when I implemented client-side error handling. And I think I'm actually processing those errors in the C++ code. So it might actually just work. Okay, well maybe the first thing we can do to test this is to start adding like a partially complete skeleton for the authentication code and just send it a malformed message, and then we can watch it handle the error. Oh, is the stream encoder having trouble with the text? Let me try making my font bigger. Oh, I might have to make some more tea. I'm gonna get too sleepy without tea. Such cameras. Oh. Oh, the debug output. I see. Yeah, I don't. Oh, how do I make the debug output bigger? I don't know. I'd rather just replace that as soon as I can. Okay, so here's where the authentication code goes. I'm going to leave that comment in place because I'm not going to actually add the authentication quite yet. Let's refer to the rapid.json cheat sheet to see how we construct a new document and then serialize it. Oh, hey, Tuco. Oh, I have a cat. That's right, so there's this intermediate step where you make a writer. So first, I need a place to put this buffer. Maybe I should be using the rapid.json namespace. You don't want to do that in the header files where you're forcing all the modules into it, but here locally, that's not a bad decision, I think. Does make this a lot less verbose. That's nice. Yeah. Got to keep checking to see, like, oh, does this want a reference? Does it want a pointer? And like, I get used to the Rust style where you are always putting a ampersand in front of things when you want to take a reference, but that's not how references in C++ work. Oh, and this can go to local send, since we are on the local thread. If we sent it to send, that would work just fine. It would just get delayed. Buffer. So we'll start with local send. We might try send also from right here later. Okay, I need to make a document. expecting here for authentication? Is huge. So it's not a command, it's not a message. Oh, that's right. This is actually part of the web interface. It's not part of the message bus. So it's an auth response. Hey, Tuco. There it is. Okay, it's just digest. I hear you, Tuke. Add member? That seems nice. Hey, Tuke. Let's check the cat detector. Oh, of course it doesn't compile right now. Check the cat detector next time it compiles. This should be sending an empty document. Like this on its own should compile, I think. Hey, Tuke. Hey. Do you have a bolt for me? Oh, Tuco. I missed this namespace. Frame opcode value. Oh man, okay. I think writer is also in a separate header file, yeah. It would help to spell this right. Hey, Tuco. I just need to capitalize that. I think that's the problem. Alright, I got some person, bottle, handbag action here. Hey, Duke. Cat. Oh, we got some cat detections. Sports ball. Suitcase, cell phone. Yeah. Dog robot. Yeah, this is, if you're just showing up in the Gitter, then yes, that is the chat channel we set up to have a hangout that works even between streams. And even among the multiple streams. So yeah, and the telemetry seems to be coming through here pretty nicely. Yeah, look at all those cat detections. This is great. Can't wait to visualize this. So I think right there we were just probably uneventfully sending a bunch of empty JSON frames. Let's see if we can send it something malformed, at least. I think there's a function like set member, add member, I guess. Name, value, allocator. I think all their code uses D for the document because they end up specifying that pretty frequently. So then you want to make the document an object. I think that might actually be... Oh... No, the object isn't actually called digest. The object is called something else. It's called an auth response, and then inside that there's a digest. What were those copy semantics that I was supposed to be paying attention to? Yeah, okay, move semantics. Cool. I think we want something like that. So this also should be pretty uneventful and just give the wrong digest. Is that a breakpoint maybe? Oh, and we hit the breakpoint. Ooh, nice. Auth response, digest. That looks great. Okay. We are well on our way to providing the correct digest at this rate. I'd like to see an error, though. Let's maybe provoke an error. See, that'll provoke an error. Oops. Just corrupting the first character in that string, which should keep it from parsing, right? Oh, it's const. Well, sucks for const. Don't try this at home, kids. Oh, Leandro is spotting what looks like a leaking string buffer. I'm actually sending that to a callback, which will then just delete it later. I'm using that as part of my cross-thread communication. Okay. Where's the output? I feel like we should be getting errors. Huh. Oh, here's the error. Yay, they're just buried under all these other messages. Code, parse failed, message, expected value at line 1, column 1. Cool. So we know our error path works. Stop doing that now. All right. Okay, we can fix that. Yeah, maybe that is next. We do need to get authenticated. This should be triggering an authentication fail. Let's maybe try turning off some of the computer vision spam so we can see the rest of the error messages. Oh, this doesn't want that to be a C string, probably. That's fine. I thought I saw a special case for strings. Maybe we do have to convert it to an object first. Yeah, I was looking at this string ref type value. Or some kind of standard basic string compatible type. Seems like we should have one of those. Oh, it's having trouble with that first. Huh. Because it was working when they were both string literals. Yeah, that compiles. That shouldn't be necessary, right? No, more helpful. Wow, can I just wrap a value, or wrap a string in a value with the value constructor? Yeah. Okay, that'll do. Okay, anyway, let's look at what the digest actually needs to do. So the other implementation we have of this is in JavaScript. That's what we're replicating. So when authenticate is called, oh, Tuco is down here right by my feet. Hey, Tuco. What a good cat. So if we're actually doing the thing, it just does this hmax SHA-512 with the challenge and the key and sends it back in base64. So I think we just need to find the right library to do this in C++ with the pieces we have. Oh, hey, Tuke. So there's OpenSSL. Whose library is this? Does this have Shaw? Yeah, Leandro suggests the Windows Crypto API. Yeah, maybe. Maybe it's not to use something platform specific if there's an easy platform independent library I could use instead. Open SSL. So I'm getting this from Crypto.js. Do I not have this all downloaded? Oh, there it is. HMAC helper sounds tasty. I really not like. I really like to not have to implement all of this myself. You'd think that if C++ of all things would, somebody would have an HMAC and a SHA-512 that I could plug together. Does not support 512. I guess not. SSL. Oh yeah, this seems like what I want. So how good is this library at just being embedded in stuff? Does it need a bunch of dependencies? Is this on GitHub? I've been using submodules so far for all my plugin dependencies, and it would be nice to continue that. What does this want to build with? This may not actually be easier to integrate than OpenSSL, but let's find out. Maybe somebody already has a CMake version, or like a CMake wrapper around this, which might be handy. Yeah, sure. Ugh, that's annoying. think this is what I'm looking for. Hasn't been updated in a while. Guess this one is more recent. This is from before they added it and then removed it from the official releases. I don't suppose anybody else anywhere in this build tree is already using OpenSSL, because that would be convenient maybe. Alright, maybe let's look at this Windows API. Yeah, this might be an alright way to do it. Wincrypt.h. Not in the header file though, let's keep this in the implementation. Alright, so we need an HMAC info. Essay full. What does that even mean? This is just the actual library implementation you're choosing. Who do you trust to implement these algorithms? Maybe I'm misunderstanding this. What is going on here? Alright, they call this the general purpose provider. I'm only using the hashing parts of it. What's this API called? specifying the hash algorithm up here when I create the hash, and then specifying it again when I supply info about the HMAC. Oh, actually, maybe this is just the example being complicated because they're deriving a key. I already have a key. Oh, okay. I think that's... yeah, okay. HMAC. Where's that key to it? I want to know how to create a key. Okay, the key is stored in a string. Somebody grabbing it out of our memory is not part of the threat model. The connection is not even encrypted. This is not super high security. This is just preventing random people on the LAN from connecting. So, auth key. That size include this header? this API might be annoying enough that it's worth just using something cross-platform like Crypto++, which looks easy to use and fine to use. It's just then if it's not just something I can slurp in with a submodule and CMake, then it complicates the build. Like, this is designed for higher levels of security than what we're trying to achieve right here. I think we just want, we want to create a blob header that says the key is a symmetric key. Yeah, I mean, this is all centered around doing this stuff on a separate crypto processor, which is great, but not really what I want. I just want this one algorithm. So let's backtrack a bit. I don't really want to use this API. Nope. Let's instead just find somebody's random C++ thing on GitHub that we can use, which seems like it might be a Crypto++ port to CMake. This is the one that said it was obsolete, right? Oh, maybe not. Let's try this route. Derry Bryson says, hello, am I on the main chat? I think you are. Oh, are you D. Bryson from the Twitch chat? Yeah, I think you made it. Just, there's a little bit of a lag. Okay, let's see if we can just add that to our CMake build. How does that work? Add subdirectory. Let's see what happens. Just compiling all the usual stuff. Yeah, it's kind of a weird time to be streaming, but looks like there's 27 of you watching on YouTube, and how many on Twitch? It's a little off screen. 10 people on Twitch. So yeah, a smaller, more cozy stream than usual. Why is it recompiling everything? Just because I added another sub-project. Oh, well. I mean, I don't mind waiting for it to compile. I'm just not quite sure if the thing I did worked correctly. Brr. I hope this has base 64. Yay. This documentation is kind of dense. Yeah, this late night, low energy, fixing the compile kind of stream doesn't really lead to long rambling conversations, I guess. You do have sock cam. Absent any actual socks right now. Oh, we're getting warnings from CryptoPP. That's a good sign. I'm not 100% sure the build products are all going to end up in the right place. I'm hoping it's linking this into my DLL instead of making another DLL. Or making a static library that it won't use for anything. Well, it looks like it might actually succeed. So let's leave that alone for a sec. I just need to get the flavor for this API. Are you going to tell me which header files I need for any of that? What? There's a test project. No. Okay, so this is registering a library with CMake. I think we just need to add that to the high-level directory. And I think we can set these options. Ah, cool. So this lets me... Terry Bryson says, "What is this channel?" It's the chat. It's the chat for Scanlime Live. You mean like what is the chat channel or what is the video channel? Because the chat channel is just where people hang out related to the video. And the video is where we work on projects, sometimes related to the chat. Right now the project is a bunch of software deep in the bowels of this robot, but in this case I'm trying to get the computer vision results out of this one thread into a different process. And still building that crypt test. Oh, I might need to edit that in the CMake cache since it was already added to the cache. CryptoPP build tests. It's also got all those accelerations disabled by default, but that's fine because I don't care how fast this code runs. It's just for authentication. Oh yeah, I mean if you're trying to talk to me specifically, you could use any of the channels, but this one also goes on the video. And I'm a little bit more attentive to it. It still seems to be trying to build a test. Let's try this again in case Visual C just didn't load the latest files. No. Oh, CryptoPP showed up here as a separate project. Do I just need to take crypt test out of the all build? This FIPS test thing. How do I disable all of this? I mean, we could also maybe disable this Win32 available check, because the actual problems are happening with some... This first string is not a wide string, and the API expects it to be a wide string. So this code is just wrong. Or like at least wrong for the current build type. I could also just fork this Git repo. That's just making assumptions all over. I'm going to have to fork this. This just doesn't compile on Windows. Alright. This also means I'm going to redo this submodule here. Okay. Oh yeah, it's not a bother. Don't worry about it. Talking on the chat is kind of fine. It's totally actually fine. Okay. Nope. So this is the one we liked. Okay, same thing, but now we can actually write to the repo. Let's just set this to off by default since we can just do that. And then fix the build error. Capital L. Soon we'll know if this compiles. Sockcam. We have all this exciting computer vision to go on, and just need a little bit of boring crypto before we can share it. It just keeps getting the same warnings every time it parses this couple of header files. It's a lot of building. Why are we still even trying to build crypt test? What? Why does output debug string want only a wide string right here? Yeah, I feel like we should be getting output debug string, not output debug string W. Where's that coming from? I think we might just still have the wrong build parameters here. It's probably time to stop this, because I'm getting too tired to feel especially useful. The problem we're running into here is that it wants to do some string concatenation, and it's assuming these are not wide strings. And then output debug string is going to want it to be Unicode anyway, and that's just not what I want here. And this whole file isn't even stuff I care about. Why is crypt test building? Oh, I don't see it in the list anymore. Crypt test. Maybe that did actually go away when it reloaded the files. Oh, wow. D. Bryson, I don't understand why you're having a hard time with this. Like, I see the stuff as soon as you type it, and then sometimes I respond. Sometimes I'm looking at other things and then I respond later. Trying to build this now. Okay, so why are we not getting a static library? Is the static library off by default somehow? Oh, or is this just failing because this isn't building? We might be close, actually. Okay, I might just blunder through this by commenting this out. Actually, I can be slightly less useless than that by just doing it this way. Doesn't output debug string have like a printf built in? Maybe not. Okay, guess not. Yeah, that's fine. Alright, so that'll still be a debug message, just slightly less good one. I'm okay with having a shoddy fork of CryptoPP in my TucoFlyer project. Oh, it compiled! It compiled. Oh, that's great. Oh, that's like a second wind. Maybe it's beer o'clock. It compiled. Okay, it still doesn't shut down cleanly, but that's fine. Okay, let's check this in, get a beer, and then maybe see if I can get this working. Oh, this is still on the old... Uh-oh. Oh, I've had this problem before. This was still in the GitHub cache. I hate the submodule cache. It's always messing me up. Okay. Let's fix this first and then fix the submodule. Git push jazz hands. Okay. Great. Yay. And I think that's right, other than the different capitalization. I feel like I just did something really sketchy with my submodule cache, but maybe it's fine. Because this is pointing to the right repo. This has got the right remote. And I think the hash in here is a hash that exists in the right repository. So I think we're fine. I'll be right back with, I need to use the restroom, and then I'll bring back a beer and see if I can actually get this to send a message. Oh yeah, switching from tea to beer. This is the moment when it would just foam up and overflow, right? At least the robot isn't actually on the desk now that it's hovering above the desk. Oh. I saw the thumbnail in the chat and I thought the stream had restarted. Okay. Let's figure out how to actually use crypto++. I would like a couple of complete examples just so we can get a feel for even like what header files things are in. Yeah, these have the same problem. Alright, let's just look at the headers. Is there a cryptopp.h? Cryptlib.h. I keep hearing what sounds like Tuco nearby. Maybe he's farther away than I thought. It is cold over here, and it's just me. Okay, the headers are all non-obvious. These are all just, the header files are not actually namespaced. Okay. They're doing more of this source and sync stuff. Which seems useful. I mean, we want to go from the challenge text to an HMAC, which will be binary, and then through the base64 encoder back to text. Oh, yeah, no worries. It's easy to have misunderstandings when there's chat and a delay, so yeah, no worries at all. So I think I want to use a hash filter. And the question is, well, what polarity is it? Does it have a sync on the front side and a source on the other side, or vice versa? Source and sync APIs, I like them, but they tend to get complicated. Let's see what this hash filter looks like. That can be another filter, so like the base64 encoder. Yeah. really want a new right there? Who owns that pointer? Skeptical. My memory leak sense is tingling. Where is attach? I'm pretty sure this attachment couldn't have ownership, right? Proxy filter. This is doing the same thing. Skeptical. I mean, it's not the end of the world if I leak like 100 bytes of memory every time this reconnects. But it's not how I like to write C code. The docs are just ambiguous about who owns this, so from what I've seen so far. But it looks like all the examples, they're passing a newly allocated pointer. There's this concept of an attached transformation. Attachment.reset. Member pointer. I guess that means it's owned by that object. That's an STL thing, right? No, it isn't an STL thing. This is a crypto PP smart pointer. Okay. Alright, so it's taking ownership of a smart pointer. Yeah. I think that one's an owned pointer too. Yeah. Let's just memory allocate all the things. Why would you want to do anything statically? String source, sure. Is there a default for that? String source. Z-string, yeah, cool. Yeah, we'll just stack these. Do I have to make it go, or does it just go? I think it just goes. Neat. That should just slurp all the data. Let's see if that even compiles. It's going to do computer vision on that image right below me. I'm going to see if it identifies feet. No such file or directory. Yeah. A decent number of people watching, given that it's so late in most of the time zones. I just want to see the computer vision output in real time. I feel like we're getting so close to having that particular Rube Goldberg machine working. Oh, I don't have std in my namespace because it's tiny and I like having the explicit prefix. Is that in a namespace too? It is. Oh, nice. Whisperfist is in East Coast Australia. Cool. Yeah, stream computer vision detecting bicycles number 1 through 33. You are seeing into the future here. that's not where I expected to see the problem. Can we just do that? Oh, hey, Tuco. This doesn't want the allocator, does it? No. Oh man, I kind of missed late night coding. It's been a while since I've done this. And it's nice. It's not even that late yet, it's not even midnight. I'm just feeling the urge to actually get this working. Where are the constructors? Oh yeah, it does want the allocator. It wants std string and an allocator. Oh, this is, I don't want a copy of that though. Yeah, I want a reference. How do I make one of these? String ref. Okay, let's try that. Oh, const char to const byte. Interesting. Where does byte come from? Is this in the standard somewhere? Is it this? I mean, I want to just cast that into bytes. Nice. Temkin says, I feel like someone should make a big piece of art in which they collect the first n things convolutional neural net recognizes as a bicycle. Oh my god, it compiled and it's running. Let's try running it with a breakpoint so we can watch this do its thing. There we go. It allocates so much memory before it even gets to this point. All right. So we have some local variables. All right, we have a challenge, which is this nonsense here. We do all that. There's our base64 encoded thing. We stuff it into a JSON blob. And here it is on JSON blob. Yeah. Let's see if we get a response. Let's set a breakpoint in this auth status packet. Huh. Got another breakpoint in challenge. Are those some reconnects, maybe? Oh, interesting. We got an error message because the message was wrong. It was supposed to be auth, not auth response. That's an easy fix. So we wouldn't have gotten the auth status response because the server wouldn't have even gotten the message because the serializer would have blocked it. We're running it again. It's blocked on the challenge. Oh, we got a status. It says authentication failed. Well, at least it got the message. Nope, still failed. I think we just get these reconnects because I've been introducing a lot of delay here with the debugger. All right. Is it possible we got the key and the challenge backwards? JavaScript version again. HMAC 512, auth challenge, key. Not much to go on there. Looking at the Rust version of the same code. That's right. Auth. Okay. Base 64 decode. HMAC SHA 512. That looks right. Key challenge. Verify. I don't see anything wrong with that. Hey, to go. Oh, there's so much junk in here. It's growing a buffer. Oh, Tuco is hanging out on my foot, and it's really cute. I guess we've been wanting to try out the computer vision cat detector. wonder if it'll detect a cat in such little light. I'm sure if it was trained to detect Tuco, this would work a lot better. Oh. Oh, we're sending a bunch of fluff messages with our computer vision. And we have some persons. I don't see any cat. Got that motorbike. Oh, there was a couple of flashes of cat. I think even just a little bit of cat detection with any kind of reliability will cause the correlation tracker to snap to that location. We don't even have an object type defined for this yet. Here you can see the authentication failing. There's some cat detection. Zachary has a good question. They're asking, is my goal to have the flyer move and follow Tuco around, or put the flyer in a certain position and then have the camera keep him in frame, or both? Definitely both. Yeah, I think either of those on their own would be kind of boring, but the combination of the two should be pretty neat. So the two things to do now are to fix the authentication and to actually have it pack the computer vision results into a message that the Rust server will accept. I'm still kind of running out of steam though. Maybe I should save this for tomorrow. So yeah, the computer vision stuff would be one of these command messages. Yeah, maybe this is a good time to wrap up. I kind of need to use the restroom again anyway, but I think I'm just tired enough that maybe I should pick this up tomorrow. Yeah, implemented it, doesn't work. Oh, so sad. Alright, well, let's resume debugging this tomorrow. So close, not quite working. But thanks for tuning in, folks. I'll see you next time as we continue this saga. I just had like 30 separate tray icons for OBS in my taskbar, but you didn't get to see that. See you next time.